Alright? Good day everyone. My name is Hosea Yakubu. You're welcome to another session of the Mathematics for the African Child. Today I want to discuss on sequences. Particularly I will focus on linear sequence. What is a sequence? A sequence is simply a set where the members are arranged in a definite pattern. The difference between a set and a sequence is that the members of a set are not arranged in a definite pattern, while in sequence, the members are arranged in a definite pattern. And the members of a sequence are called terms, not just elements. They are called terms because of the pattern of arrangement. Now, there are two basic aspects of sequence. One is the linear sequence, and we also have the exponential sequence. But for today, I will discuss on linear sequence. A linear sequence is simply a sequence where its terms are generated by adding a particular number to a preceding term to get the next term. That's a linear sequence. By adding a particular number, the number could be positive or negative to a preceding term to get the next term. That's a linear sequence. Now, suppose we have T1, T2, T3, T4 up to Tn to be terms in a linear sequence. Terms in a linear sequence. Now, the common number that is added to a preceding term to get the next term is called the common difference, and it is always denoted by small letter d. Small letter d. Now, if we have something like that where n here is the number of terms, so if we have this, since you add a particular number to a preceding term to get the next term, there are certain computations that we need to take note of. But before then, we need to note that T1 is always denoted by small letter a. T1 is always called a. Now, if we have this, to get our T2, we can just work out some simple computations. Now, D will always be equal to T2 minus T1 being equal to T3 minus T2 being equal to T4 minus T3 up to equal to Tn minus T4. Very simple principle. So it means that D is equal to T2 minus T1. And this same D could be equal to T3 minus T2. This same D will be equal to T4 minus T3. So from there, we can proceed by saying, if I want to find T2, since T1 is equal to A, and I want to find T2, what do I need to do? I will now say, okay, from this relationship where D is equal to T2 minus T1, is that? I will now say, but my T1 is equal to A. So if I substitute T1 into the above, the value of T1 into the above relationship, that will now give me D will be equal to T2 minus A. Then for me to find T2, I will add the additive inverse of minus A to both sides. That will now give me T2 will be equal to D plus A. So this is for T2. Now if I want to find T3, I will now equate this D with this. That will now be D being equal to T3 minus T2. So if I have that now, I can now say, okay, that implies that, T3 will be equal to D plus T2. I'll now say, but T2 will be equal to A, or let's say D plus A. That's from this. If we substitute this value into this relationship, we can easily have this. That will now have be T3 will be equal to D plus A. So if you open this bracket, T3 will be equal to D plus D. That will give us 2D plus A. Sorry, this is A. So that we're not mistaking it to 9. T3 plus A. So T1 is A, T2 is D plus A, T3 is 2D plus A. Let me proceed. If we want to find for T4, we can now relate D with T4 minus T3. Now we'll have D being equal to T4 minus T3. If we're looking for T4, it implies that T4 will be equal to D plus T3. And I'll say, but T3 is equal to 2D plus A. When you substitute into this, T4 will be equal to D plus 2D plus A. Now, we'll end up having something like this. T4 will be equal to 3D plus A. And this is our value for T4. From what we've done, you will now notice that in a linear sequence, T1 is equal to A, T2 is equal to A plus D, T3 is equal to A plus 2D, T4 is equal to A plus 3D. What do you think T5 will be? Using a simple deduction, T5 will be equal to what? A plus what? 4D. Then if you go further, T6 will be equal to what? A plus 5D. T7 will be equal to A plus what? 6D. Sorry, 6D. In fact, if you have T100, that will be equal to A plus 99D. So, by deduction, if we have Tn, what will be our result? Our result will be A plus, did you notice that n is being reduced here by 1? If this place is 100, this place is 99. So 100 is being reduced by 1. So n here will now be n minus 1d. That is our very simple formula by deduction. Okay, now from what we've done, suppose we are given, look at this question, they said, what is the 15th term of the sequence this? Now, what they're asking you is, they're asking us for T15. Now, looking at the sequence we have, A is equal to what? Let's say T1 is being equal to A and is equal to minus 3. Is that? Now you have T2, you have T3. Now, if you want to find our D, now D will be equal to T2 minus T1. So if we have that now our D will be equal to 2 minus 3, like this. So our D will be equal to 2 plus 3. D will be equal to 5. So we've gotten our D. Now we go back, since we have our A and our D, we now go back to T15. T15 is simply A plus 14D. So what do we do now? We end up having T15 will be equal to, what is our A? Our A is already given as minus 3, then plus 14 into our d is 5. 5. So that will now be T15 will be what? Minus 3. 14 times 5, that will be plus 70. Is that? So T15 will be equal to what? 67. That's all. We'll go on the second one. The second one is brainy. On the second example, we are given, look at the question. The 6th and the 13th terms of a linear sequence are 0 and 14 respectively. Find the sequence. Find the sequence. So, a linear sequence is also called an arithmetic progression. So look at this. I will now have my T6. T6 is actually given by A plus 5D. And it is equal to 0. Here is it. Then T13 is actually given by A plus 12D. And it is equal to 14. So, if we are asked to find the sequence, very simple, we can now say, okay, from this now, it implies that A plus 5D being equal to 0, you call it equation 1, and A plus 12D being equal to 14, equation 2, you are just nicknaming the equations. So, since you use simultaneous equations, since the term in A in equation 1 and the term in A in equation 2 are the same, what you now need to do is to subtract equation 2 from 1 to eliminate the term in A. When we do that, see what we have here. We have minus 7D being equal to minus 14. So when we go further, now D will be equal to 2. We've gotten our D. We can now substitute the value of D into any of the original equations. Here, that's equation 1, to find our A. So let's do that. We end up having A plus, equation 1 states that A plus 5D is equal to 0. So our D is 2. That will now be A plus 5 into 2 being equal to 0. Now we have A will be equal to, A plus 10. If you expand this bracket, will be equal to 0. Add the additive inverse of 10 to both sides. A will be equal to minus 10. Now that we are able to have our A, able to have 10, is that as easy as for us to be able to find the A is the sequence. If we now have A being equal to 10, by the time we add 2 to 10, A is equal to minus 10. If we add 2 to minus 10, now the second, that's T2, will be equal to what? Will be equal to minus 10 plus 2. T3 will be equal to, this will be equal to minus 8. Now T3 will be equal to minus 8 plus 2. Now T3 will be equal to minus 6, and so on and so forth. So the sequence will now be minus 10, comma, minus 8, comma, minus 6, comma, dot, dot, dot. This is the sequence. Alright? Thank you. If you like this video, please, you subscribe and click on the notification button for subsequent